Hi there and thanks for watching. If you like the content of this video, please like and subscribe. Hi, my name is Jonathan Hopp and I am the instructor for this 2-hour introductory Java course. This course is aimed at people who are complete beginners at programming and complete beginners at Java. So if that's you, you're in the right place. More advanced programmers may find that the pace of this course is a little bit slow. If you're starting off at programming or are wondering which language to start off with, Java is a really good first choice. To do this course, you're going to need to download IntelliJ Community, which is the IDE, or basically the program I'm using to code in Java. That way you can follow along. It's very important as a beginner that you follow along by actually typing. All right, just watching a video is only going to get you so far. You're going to have to actually put your fingers to the keyboard. There are a variety of topics in this course, but by no means am I covering everything about the language of Java, just the basics to get you started. All right, let's get into it. All right, let's get started. So hopefully you have IntelliJ Community already downloaded and installed on your computer. This is the program we're going to use to code in Java. All right, so we need to make a project in order to get started. So we're going to do new project in the upper right-hand corner of the screen. And then under name, you can put what you want with no spaces. So like my brand new project. So you can give it like a more descriptive name. You pick the location on your computer. I have a coding folder. If you're learning how to code, I would say have a folder where you put your projects at, which is very convenient. Our language is going to be Java. Our build system will be Maven. And for the JDK, I'm not super stickety about it. If you get anything 17 or above, you're probably good. It allows you to download the JDK as well if you don't already have that installed on your computer. After that, you hit create, and then it will create a project. So you've got an idea folder, a source folder, a pom.xml, a thing that says external libraries, and if you go into the main folder, you'll notice you have a blue Java folder. Okay, if it looks like this, you're ready to get started. Let's make our first program in Java, which is actually really simple. All right, so I've got my new project. I'm using IntelliJ, and I've made a Maven project. All right, if you saw the previous section, you should know how to do that. I'm going to find my Java folder, which is in blue here. I'm going to right-click, and then I'm going to create a new package. All right, so we need to place our classes and all our JavaScript code into different packages. So let's keep it simple. As far as the name, I'm just going to call it like com.mainMethodExample. Package names are based off what you want to name them. There is not too much to it. You have basically like dots to say like which package is above the other one, but we'll get more into that later when we have to have more packages. For right now, I'm just going to call it com.mainMethodExample. And then now I got my package, which you can see by this icon with a dot on it. And inside this package, we can start putting our classes. So our goal today is just to make the main method, the method that the Java will start up when the Java program begins. So I'm going to right-click on the package and do New Java Class with this C to the left, little blue C in IntelliJ. Right, and then it'll bring up this little menu. I'm just going to call this main. All right, so now we've got our main class, and I am going to type the magic spell. All right, this is the magic spell that all Java developers must know. It is a basic spell. It is public static void main string args. Okay, that is the magic spell. All right, that you must put into your Java program for it to start. So what this means is that when we start a Java program, we're going to put other stuff in here eventually as we become better coders. But for right now, we have this one method in our Java class here in main. And when our program starts, it will run this. So what I'm going to do now is I'm going to type the words S out. Notice how IntelliJ brings up this little like sort of recommendation. If you hit tab, it will basically print out this whole thing for you. So we'll say system.out.println. You could, of course, write it yourself, system.out.println. However, that's a lot of typing, and so I would rather just type S out and then hit tab and then have it do that whole thing for me. And then, of course, as is per tradition, we must do hello world. Okay, and now we're going to run it. So go up to the upper right of IntelliJ where you see this green arrow to like run, says run main.java. When we click it, Java will compile, do a little build, you see some stuff going on the bottom, and then the terminal will pop up and it will show hello world. So that means that this public static void main string args is the method that is going to basically be the entryway into our program. There's going to be a ton of other things, but we need this public static void main string args in order for the Java program to basically get started. All right, this is all Java programs need to have a function like this, so that the program knows, hey, I go here when the program starts. All right. Let's get to understand our tool IntelliJ and a little bit more about Java so that you understand how the programming process is going to work. Java is a compiled language, so it is unlike JavaScript, meaning that the computer needs to build the program before it runs. What I mean by build is essentially it takes the code that you write, turns it into ones and zeros that the computer understands, and then runs it. Now this process happens away from you. You don't really need to see all the nitty-gritty of how compilation happens because we have this IntelliJ community to help us. IntelliJ streamlines a lot of these processes that used to be, frankly speaking, very annoying. All right, so we have public class main, and just like in our last video, we made a main function. There's nothing really in it. So if I want my program to actually do something, let's do sout. And then just do hello world like we did last time. Now, if you'd like to know whether or not your program is capable of running, whether or not it has any errors, because it will not run if there are errors, because Java is a compiled language, Java will check to see like, hey, is everything all right? Does everything follow the rules of Java? If it doesn't, it will let you know. At the top, you can go to build and do build project, okay, and wait a few seconds for IntelliJ to do its thing. And then it will let you know whether it found any problems or not. If it didn't, you're all good. The build will be successful, and it will say build completed successfully. Otherwise, it will say, okay, there was a problem. So for example, let's say I get rid of the semicolon, all right? You're going to see these red squiggly lines, meaning that, hey, IntelliJ is expecting a semicolon, because at Java, the end of our thought, the end of a line should have a semicolon like this. So IntelliJ is there to kind of help us make certain that we don't make these kind of mistakes. But let's say we did. Notice on the left side, everything is red, right? So it says, okay, cool, like there is a problem here. And if you try to build it, then you're going to get to what's this build output screen, and it will actually go to the line where it's having a problem and tell you what the problem is. All right, this has to all be worked out before you can run the program. Now, if you like to run the program, you can run it from this green arrow up in the upper right, up here, all right? And you also can go into the run section in the lower left, or right here, run next to version control, and use this green arrow here, all right? So again, Java is compiled, meaning that it takes the program and turns it into ones and zeros. IntelliJ exists to help us find errors in our Java before we try to build, because again, Java will not run if there are any errors in the Java, meaning like you're forgetting semicolons or the syntax is wrong. Java will just simply not run. Okay, other languages that is not the case. Let's learn how to do variables in Java. All right, it looks pretty intimidating to beginners, but it's really not that difficult. All right, so first off, there is a pattern to how you declare a variable in your program. What I mean by that is your program has to have data that it works with. Student records, ages, inventory, I don't know, like scientific data like heights of plants, like it could be literally whatever the situation calls for. But we have data that we work with, and we have to have variables to store that data so that we can do meaningful work. Right, so it follows a pattern. First, you type the type of the variable. And when I say the word type, I don't mean like typing on a keyboard. I mean what variety of variable do you want to use. Then you give it the name, then you set it equal, and then on the right side you have the value ended by a semicolon. Let's take the easiest one of the variable types, which is string. Right, so string you can think of as like naming things. All right, so string is for like people's names, maybe for like names of famous places, things like that. Okay, so we've started off with the variable type. And again, I don't mean typing on a keyboard, I mean what variety of variable is it? It's a string, okay, with a capital S. After that, you give it the name. Let's just say that this is going to be a variable to hold my full name. So I'm going to call it full name equals, and for strings we have quotation marks, and then inside the quotation marks you can put letters, capital or lowercase, you can put numbers, you can put symbols, okay, whatever you'd like. And then we can put a semicolon at the end to indicate that we have ended the line of code. All right, and again, the pattern is string, because that is the type of variable we're working with. Full name, which is the name of the variable, we decide this, equals, and then on the right hand side we have the value of the variable, which in this case is a string, so we need quotation marks, and then inside the quotation marks I put Jonathan Hop and ended the line with a semicolon. One of the common beginner misconceptions is that the name of the variable means something to the computer. It does not. I repeat, it does not. I call this full name because that makes the most logical sense to me as a human, and for other programmers who are also human will look at this and say, okay, cool, this variable holds the person's full name. That has meaning to humans, it does not have meaning to the computer. I could just as well call this aardvark. Okay, and everything would work just as well, all right? Now, that would be confusing to other humans. Why on earth would you name a variable aardvark? But that's fine. The computer will keep chugging along. So make sure you understand that this is, again, potato. You can call whatever you'd like. So people typically name the variable the kind of data that it holds. That way everyone understands what it's for. But that's more for working with other programmers, less so for the computer itself. Now, let's talk about this type. We just learned string, okay, which is great for like people's names or places or things like that. It can hold letters. You can put symbols in here. Okay, if you want to put like an @ symbol, that's awesome. You can put numbers in here. Okay, all you want. Right? Strings are great for names. Strings are great for things like zip codes. Okay, phone numbers. Okay, things you're not going to do math on, for example. Other types of variables that exist are for numbers, which are these four. Okay, we also have a Boolean, which is for things that are true or false. And then we also have these two, which are string and char, which are for basically like letters and words. There are more obscure ones like byte and short, but you don't really need to know that as a beginner. You won't have to like actually use these for, I mean, you can go years without using these, honestly speaking. But byte is probably something you'll get to when you're more practiced with Java. All right, so let's talk about the numbers. Okay, we got int, long, float, and double. Int and long are for whole numbers. Float and double are for numbers with fractions. So in case you're not sure what that means, notice how there's a point and then there's a number over here, like 3.3 over here, etc. So that means that these are fractional numbers. They're not whole numbers. Okay, they have a whole part and a fractional part. Whereas int and long are for whole numbers. Okay, so there's no decimal after here and anything like that. You might be thinking, well, why would you have int and long and float and double? Why not just have int or float? The reason being is that there is a maximum value that int can hold, which I put here. We say, well, Jonathan, what do you mean by maximum value? Like, so we have this really big number, and if I were to go one higher than this big number, see how it has red from IntelliJ? This red, basically, IntelliJ says, hey, there's something wrong here. I'm going to hover my mouse over this. Integer number too large. All right, so basically it's saying, hey, this whole numbers, this is a variable. Okay, I just named it. Again, I could name this aardvark, okay, just as much as I want to. It doesn't matter, right? And it's an integer, but an integer cannot hold a number this big. All right, that's what that basically means. So this number is fine. Anything under it is fine. And then if you go in the opposite direction, negative, okay, this would be too small of a number for it to hold. All right, you don't have to memorize that. I really wouldn't. You can always just go look it up on Google. But as long as you understand that int and long are the difference between them is like what is the size of number that you can hold in them. For a beginner, that's good enough. I would really just recommend using int when you're first starting off with Java. It's going to just work fine for you. All right, as far as float and double, you can see that they're fractional. Again, it's about the size of the number that they can hold. Notice how for float, I put an F after the number to indicate it's a float. Double, I don't have to put anything after it. You can put a D if you'd like, but there's really not a reason to do it. The computer will not force you to. If I don't put the F here, like let's say I get rid of it, you'll notice that IntelliJ starts complaining, saying, hey, you said there was a float, but you gave me a double. So it's required type basically says, hey, this is what I'm expecting, and provided is, hey, this is what you gave me, right? So to make sure IntelliJ knows that this is a float, like, okay, cool, that's a float. You use letter F. And again, easy to remember because float begins with F. All right, so again, as a beginner, you can just stick to int and double, okay, for right now. And again, that's just to keep things nice and simple so you don't have to think too hard about it. For true or false, we have Boolean. All right, Boolean, and then the name of the variable, and this could be the word true or false. Notice how I'm not using quotes. All right, so notice how the word true is not in quotes like it's a string. It's just the word true or false. And this is great for things like off and on switches, for example. Is the light on or is the light off? There's only two options, right? So in any sort of situation where you only have two options, then Boolean works fantastic. All right, we have string, which we learned already. So we have like string superhero equals Tony Stark. All right, and put whatever superhero you want here. We also have char, which is for a single character. So it's a single letter, right? So notice I have the letter A here, right? I couldn't do AB, for example. Okay, you're going to see a Java complains. If I hover over, it's going to tell me too many characters in character literal. In English, that means that, hey, a char is supposed to be a single letter. So that's what you got to do. Now notice that Java is very particular about how you type things, all right, and what data goes where. It is a statically typed language. Basically, what you can think of is that Java is looking over your shoulder as you program, making certain that everything is in its right place. So what that means, therefore, is that we can't switch these things around. So, for example, on line 6, I have a variable called full name, which is a string, which currently holds Jonathan Hop. If I take this variable and try to change it, so let's say I'd say, okay, full name equals Fred Flintstone. This is fine, okay? I can change the value of my variable by just saying the variable name equals and then whatever the heck else I want to put over here. The thing with Java, though, again, with being statically typed, means that once you declare full name, the variable called full name is a string, it's a string for the rest of time. I cannot do this. Full name equals 10. Okay, that will have a compiler error. This red mark tells you, hey, I can't run. If you hover over it, it will basically say like it's a string, but you gave me an integer. You will not be able to run the program. Do not pass go. Do not collect $200. Right? C# works in much the same way. You'll find other statically typed languages will basically check to make certain that your variables stay the same type. All right. So now we know how to make a variable by having the type, giving a name for the variable which we choose. This could be what we want. Equals, and then the value on the right-hand side followed by a semicolon. We can also change the value of a variable we've already created by writing the variable name. We don't have to put the type in front because Java already knows it's a string because we put that on line 6. Then we can set equal to whatever the new value we want. We have to make certain, though, that when we have a variable that the information inside of it matches up. So if we say a variable is a string, then we can change the variable as long as it's to a string. We cannot take that same variable and make it into a double or a boolean because we already told Java that this variable full name is a string. The cool thing about it is if you don't totally get it, as you code, IntelliJ will help you because IntelliJ will let you know whether or not Java will compile. Remember, you will not be able to run the program so long as Java does not compile. All right, that's it for variables. So now let's use our knowledge of variables to do something a little bit more interesting. All right, because variables by themselves don't do much. We want to actually take those variables and make our program do things. All right, so we're going to use the console, okay, which is this thing at the bottom. All right, if I run my program on the upper right of IntelliJ, there should be this green arrow. All right, we're going to hit it, and then we're going to let it compile, and then right now it doesn't do anything, right? But at the bottom is a thing called the console. Okay, and we're going to start printing stuff to the console so that way we can use our variables to do interesting things. I want to make one note. The console isn't really a thing that's like used for like web pages or anything like that. So for a lot of beginners make the mistake of thinking the console is used more than it actually is. A lot of the times the console is really just used for other developers, or maybe you're making a console app, which is possible. But if you're not, like, it's not going to magically turn into a web page or anything like that. For that kind of thing, you need HTML and CSS. But the console is great for beginners because it allows us to write programs and we can immediately see the feedback. Like, we can immediately see what our program does. So that's good, but don't expect it to do anything magical other than that. All right, let's make a variable. We're going to call it username. So we're going to do string with a capital S. Username is equal to, and we'll just put, I don't know, Bob Smith. Okay, something random. All right, now as it stands, this variable is fine. We have the type, which is string, the name of the variable, which is username, and the value, which is Bob Smith. Let's actually print that out to the console. We're going to do system.out.println. Cool thing you can do with IntelliJ, you notice that like I didn't actually type all that fast. I just know that when we do system, see how I just have SY currently typed? I can hit tab and it fills the rest in for me. That way I don't have to type the entire word system. Then I do doubt, and then we see out is already there as the first thing because it's most likely the thing that you're going to pick. So I'm going to hit tab again. So I don't have to type the entire word. I hit dot, and then we're going to do print line. And again, I hit tab. All right, so actually the only real thing I actually typed on my keyboard was SY. Everything else, I use IntelliJ's what's called IntelliSense to help me fill in the rest of the line by just hitting tab. All right, now inside these parentheses, we're going to put a string. Previously, I had you guys do hello world, which is cool. Again, if we were to run this program, so we're going to hit the green arrow to compile and run, you'll see it just prints out hello world to the console. Let's do something a little bit more interesting than that. So let's actually put the value of the variable username in the console. So I'm going to type the word username. Notice how username used to be grayed out here, but now it's white. That's because the variable is actually being put to use. So if I were to remove this, you'll notice the color changes back to this darker gray, meaning that this variable, you made a variable, but you're not using it anywhere. Another cool thing is that when you're hovering over username, like see how when I click away from it, if you click on it, you'll notice it has a box around it with a different color, and then every other username is also has this box around it. That way you can kind of see like, hey, I have this variable and I'm using it in different spots, like where is it being used? That way you can visually see that. All right, let's give this a shot. I'm going to run my program. Bob Smith. Now, you can change this inside of here. Let's do Rick Grimes. All right, and then run it again. And there we go, it updates. Now you can kind of understand that variables hold values. This username is just basically holding the string Rick Grimes. So when we print it, whatever value that the variable is currently holding will be printed to the screen. All right, now our variables are doing something a little bit more interesting. So let's actually take let's ask the user what they think. Let's actually be able to grab the thing the user types in and actually do something with it. So far, our program doesn't really do anything interesting still. I mean, yes, we've got our variable, we can print it out to the console, but we decide what the value of the variable username is. So there's no interactivity in our program just yet. So we need something to be able to ask the user for, let's say, their name, right? And then print out whatever they type in. That'd be a lot more interesting. So let's take what we've got so far and get rid of it. And then let's learn about the scanner. Okay, so we have this thing called a scanner, which is a class in Java. You can think of it sort of like pre-written code that someone a long time ago, I don't know who they are, they wrote out a class called scanner that we are now going to use. All right, if you don't want to type the whole word scanner, I put SC and see how scanner popped up, and you can hit tab. You'll also notice that on line 3, it puts this import statement. Right, and imports are very important in Java. They allow us to take code from other parts and bring it into our current file. So right now we're working in the main class, we're working in the file main.java, and so we need some extra code to help us do our job. So someone wrote code for this scanner, and I'm going to use it. Okay, that's what import does. Import says go somewhere else, specifically here, and go grab the thing I want. All right, so now I have scanner. And then I'm going to type the word scanner with lowercase s. And notice how this is just like the same thing we did with string. We like string full name. Well, scanner is a type. The type of thing I'm working with is a scanner. The variable, I'm going to call it scanner. I could just as well call it aardvark. Okay, there is no, again, the name only has meaning to me, not the computer. And then I'm going to do new scanner. And inside the parentheses, I'm going to put the word system.in. All right, let me explain line 7. Okay, scanner is that class that allows us to ask the user for information. The right side is probably new to you. We have that new keyword in orange here. All right, you can think of it just basically saying, hey, I need a new scanner. All right, take this scanner. There's like a blueprint for a scanner, like a 3D printer. Like, okay, cool, 3D print me a new scanner so I can use it and ask the user what they want. All right. And then system.in, the best way to remember this is a beginner is saying, hey, I want to take in information from the user. All right, so what line 7 does, it gets a scanner set up. Set up the scanner to make it ready to use. Right, we haven't used it yet, we're just setting it up so that later we can use it. All right, let's make a program that asks the user what their name is and then prints out what they typed. All right, so I'm going to do system with a capital S, .out, .println, and then inside I'm going to put quotation marks and say, hey there, what's your name? Okay, you can put really any question you want here. I'm just going to do, hey there, what's your name? Feel free to be creative. All right, now we are going to capture what the person types in. I need a variable to hold that. The person's going to type something in and hit enter. When they hit enter, I need a variable to basically be like the baseball catcher to like catch the information that comes in. So the information is going to be a string. Okay, they're going to type a string in this case, which is going to be their name. So I'm going to say, okay, cool. String name is equal to scanner dot next line. Let's break down line 11. I need a variable to hold the value of what they type in. The user is going to type in something and they're going to hit enter. When they hit enter, whatever they type, I need to store it somewhere. Okay, I need to put it in a little box so that I can do something with it later. That's what this variable on the left-hand side is doing. On this side, this is the part where it actually captures what the user types. Okay, then on the next line, I'm going to put system.out.println. I just remember you can just type S out and hit tab. You don't have to type all that stuff out. And then I'm going to put name. That's the variable. All right, let's give this a try and see what happens. I'm going to run it. Okay, it says, hey there, what's your name? Notice how I put my cursor here after the next line. I'm going to put Jonathan Hop. Right, and there we go. It printed out my name. And this program is a lot more interesting because it will actually change based on what the person types. If I put in Rick Grimes, it will print out Rick Grimes. Whatever the person types in, it will print out. So line 11 is very important for you to understand. One of the things that beginners have a hard time understanding is that variables hold values. This scanner.nextLine is doing something. It is capturing what the person types in once they hit enter. There's a lot of steps to that. You don't need to know all the steps. All you care about as a programmer is that, hey, scanner.nextLine means the person types something in and hit enter. The thing that they typed in has to be stored somewhere else it goes into oblivion. I'm going to make this variable name to actually like save that value, whatever it is. So we don't actually know what the value of name is until the person types it out. So then after they type it out, we print it to the screen, and now our program actually will change what it does based on what the user does, which is way more interesting. All right, so we had a program that asked the user for their name, they typed it in, and then we printed out whatever they typed in. What happens if you would like to do something other than just like a string? Because NextLine does strings, so things like people's names, or maybe countries, things like that. What if we had to ask the person their age? Well, it's actually pretty simple. Scanner helps us in that regard. So I'm going to do system.out.println, and then in here I'm going to ask, how old are you? How old are you? Then on the next line, I'm going to make a variable to hold the age. And age, it makes sense for age to be a whole number, so we're going to do int for integer, age equals scanner dot, and we have NextInt. Okay, so notice how this was next line, which was a string, and this will get NextInt, which is for integers. And then we will go ahead and then print out the age, just like we did on line 12, except this time we're using a different variable. Let's run our program and see if it works. All right, what's your name? My name is John Everyman, and John Everyman is 100 years old. And there we go. If you're wondering what other kinds of information you can get the scanner to pick up, if you do scanner and then hit dot, IntelliJ will pop up a bunch of different suggestions. NextInt, NextFloat, there's a bunch of other ones, NextLong, NextDouble. So that way you can get the kind of information you'd like. Notice how scanner comes with a lot of pre-built methods. All these things with the white text and then the parentheses afterwards are methods. They're basically like pre-built functionality that we can use. So we have next line, next int, and maybe try it next double, next float, and see what you get. All right, so far our program does something a little more interesting. We ask for input, we do something with the input, and put it back out to the screen. Let's actually try to manipulate the input. Let's actually take these strings and do something a little more interesting with them other than just print them back out to the console. Here I have a program that asks the user for their first name and last name. So notice on lines 10 through 12, it asks, what's your first name? I take what they type and store it in a variable called first name, and then I take the value of first name and print it out to the console. I do exactly the same thing with the last name. So if we were to run this program, then I'd put, well, hey there, what's your first name, Jonathan? What's your last name, Hop? And then it would print it out, and that would be it. But this is kind of, a little bit clunky because I really would like it to print my name together, right? Like first name and last name together on one line. So what I'm going to do is I'm going to get rid of line 12, Then I'm going to get rid of this line here, which is now line 15. And I would like to take the variable first name and the variable last name and kind of put them together. So what we can do that is we can do combined strings, which is called string interpolation. So essentially we can just take two strings and put them together. And one easy way to do this is using basically addition. So we'll do first name plus, I'll do quotation marks to do a space, so there's a little bit of space in between the first name and last name, and then do plus last name. So now on one line it should do first name, then space, and then last name. So let's give it a try and see what happens. Alright, so what is your first name? My first name is, I don't know, Rick. Last name is Jones. See, and there we have it, Rick Jones. We can even make this a little bit, add a little bit more to it. Be like, hey there, nice to meet you. Okay. And now we can do like a full sentence and then take our variables and stick them in the sentence where we need them. All right, so we can go play. All right, we'll say, what's your first name? Peter. Last name Parker. Hey there, nice to meet you, Peter Parker. All right, that way you can take the things that the variables that you get and string them together and put them into a nice sentence like this. Plus signs are the way in which we do that. So you're going to do a string plus, and then see how I just put the variable first name here and plus, and then after that you can kind of format it the way you want to. This is very cool. There's another way to format strings, which we'll learn in the next section. All right, let's see if we can spruce some stuff up. All right, so we have a program here that asks for the person's first name, last name, and age, and then prints it out to the screen. So let's give this a try as it is. All right, first name is Harry Truman, 500. Okay, all right, and then you can see it prints out the first name, the last name, and then the age. Well, this is starting to get a little bit unwieldy, right? This is very, very long and a lot of stuff to type out. So there's another way we could write line 19 to be a little bit better. I'm going to comment out line 19 by putting 2 forward slashes, okay? So that way the computer will be like, okay, cool, this is not code. I can just skip it as I'm running along. We're going to learn a new thing called system.out.printf. Okay, instead of doing print ln, we're going to do printf. The quick way to do that is SOUF. Okay, SOUF, and then hit tab. Okay, and there you go. We're going to do formatted, all right? Now, what we can do is start typing in our normal string. So inside printf, we're going to do quotation marks because it's a string, and then start typing what you want to show. So nice to meet you. Now, here's where we want to put variables. First off, you're going to do a percent sign. Then you're going to do a letter that will indicate the type of variable that should go here. Because first name is a string, and we know that because on line 11 we said first name was a string. Okay, right here we're going to do S. So this will be first name. Then we'll do a space, and we'll do %S for the last name. And then NUR. Okay, now because we have age is not a string, age is an integer, we're going to do %D, years old. Well, Jonathan, how on earth does it know to put first name in the first spot, last name in the second spot, and age in the third spot? Like, how does it know that? We have to tell Java. So we're going to do a comma, and then after the comma, we put them in order. So the first thing I want is first name, comma, then the second thing I want is last name, and the third thing I want is age. Okay, so what this will do is it will go through this string and say, oh, I found a %S. Okay, so this must be a string. I'm going to replace this first %S with whatever is in first name. I'll do the same thing with last name, and then do the same thing with age. The reason these letters are different is because these variables are different. First name and last name are strings, as we see on line 11 and 14. Okay, line 11, string first name, line 14, string last name. They are strings. On line 17, it says int age. Age, therefore, is an integer. You put S here, you got to put D. All right, let's run our program and see what happens. We're going to put Dr. Strange, I think 1,000 years old. All right, and there we go. Hey there, nice to meet you, Dr. Strange, and you are 1,000 years old. So you can see how Java went through this string and then decided to replace the values with our variables. Whatever the person typed in got in here, okay, through these variables. Keep in mind, though, you got to make certain that you do the right letter. So, for example, let's say you mess up and change this from a D to an S. Well, age is not a string. Okay, on line 17 it says int age. Age is an integer. S is for strings. Let's see what happens if you actually put this in there. So we'll do, I don't know, Steve Bannon, who is 20 years old. Okay, in which case it will still go. Actually, it will convert it to a string, which is actually very nice. All right, so if you put in a letter that doesn't make sense, let's put I in here. Let's see what happens. Okay, what's your first name? Joe. Everybody. 50 years old. There we go. You'll see this exception. Okay, exception basically means that something went wrong, which we'll talk about in a little bit. So in case you put the wrong thing in here, it will give you a unknown format conversion exception, which basically means it doesn't know what to do with the information you got. So just keep in mind that like you need to put the right letters in here to match the types of the data that should go in there. So now you can write this same line using the technique on line 19 or the technique on line 21. It's up to you. Alright, let's learn what a method is. So a method is kind of like, basically like pre-built functionality. So let's take strings for example. Let's say I have a string that says string full name is equal to Jonathan Hop. Right? Now, I have this name, and let's say for example, actually let's go make it all lowercase. Let's say it would look like this, alright? And I would like it to be all uppercase. Well, I could probably program that myself, using some Java, or I can use a pre-built Java method, all right, that basically comes with strings that allows me to make my string uppercase. Methods are signified usually with a parentheses afterwards. So let's actually take a look at it. So I have this variable called full name, which is a string, and there are certain pieces of functionality that are tied to strings. IntelliJ can help you out by, when you hit dot, it will pop up a bunch of methods, all right? They have that M with the red dot, and there's, as you can see, there are a bunch, and all of these are basically pre-programmed functionality that comes with strings. Okay, if I'm using a string, I get these. So I want to make mine uppercase. So I'm going to pick to uppercase as my method, and then do a semicolon. Notice it has this parentheses afterwards to indicate that it is a method. So I am going to go ahead and call this. In fact, I'm going to print it out. So I would like to go to the screen. I'm going to print out this variable full name, whatever's in it, to uppercase. And let's see what it does. Okay, there we go. All the letters are uppercase. So this method is just basically pre-programmed functionality. Could I write my own code that would take a string and make all the letters uppercase? Of course I could. Or I could just take the method that someone already wrote and then use it myself. Notice that methods are indicated by this parentheses afterwards. If you ever want to know what methods are available to you, you can always type the variable and do dot, and you can look. Full name is a string, so these are methods that are tied to strings. Not everything has the same methods, all right? So you're going to have to, as you program, learn which methods apply to which types. So strings have certain methods, integers have certain methods. They all happen to be a little bit different. But you'll notice that they pertain to what you're working with. So if I'm working with a string, making something all uppercase or making something all lowercase makes a lot of sense. So for example, let's rewrite this. This is in all caps like that, all right? And I'm going to go ahead and run the program. All right, and as you can see, the to lowercase method was able to take this string and write it completely to lowercase. Now, remember, that's for strings. So if I have like int some number equals 10, I do some number dot, you'll notice that it doesn't have all those methods that we just saw, right? Like to uppercase to lowercase, because some number is an integer, and integers don't have the same methods that strings do, because, well, you work with them differently. Okay, and then you can always do something as a method, because you're looking at these parentheses afterwards. It would not be correct to have it like this. You'll notice that IntelliJ makes this red, and it's like, what the heck is this? I don't understand what you want me to do. When you do these parentheses, you're saying, okay, I want you to do the method. I want you to actually carry out the functionality of what I'm asking you to do. So like to lowercase or to uppercase. All right, those are the ones for strings. And again, there's a bunch of them that you're going to learn over the course of your career as a Java programmer. Right, and when they are relevant, I will bring them up. But now you understand what the method is. So now that we know what methods are, let's actually learn more methods that are related to strings, so that way we can do some cool stuff. All right, let's say you have a string. I'm going to call it name is equal to Natasha Romanov. All right, so again, we begin with what type of variable is it? I don't mean computer typing, I mean what variety of variable is it? String. I gave it a name. This is potato. I can name whatever I want. And then it equals Natasha Romanov. All right, then we're going to print out. Let's say the question was, how many characters are there in this string? Well, there's a method for that. We're going to do name.length. Okay. Notice how after the word length there are parentheses to indicate this is a method, meaning, hey, I want you to go do this. Okay. Methods are functionality. You want the computer to do some work. Okay. And you're telling the computer, okay, I want you to actually do this. All right. So we're going to run it and see what happens. Give us 15. So let's count how many characters are here. So start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Notice how I counted the space in between the first name and the last name. It counts. So there are 15 characters in this string. So the dot length, that method length, allows us to know how many characters, including blank spaces, there are in the string. If I were to change this, then it would be different. So I can do ABC, and then it should come out as 3. All right, there we go. If you add spaces at the end, they do count. So I put 2 spaces at the end, so it should come out 5. And it does. All right, well, that's kind of annoying because, like, what if there's, like, spaces? I just want to count all the stuff but with no spaces. Well, we've got a method for that too. You can even chain them. So we could do it like this. So first we could do it the long way. Name is equal to name.trim. All right, what .trim does is it takes the string and gets rid of all the white space. So to understand what line 7 is doing, I'm telling it, hey, take the name and get rid of all the extra white space and take that new string and save it as name. So I'm taking the same variable and changing the value around. So hopefully I'll get the name will be without all this extra white space. If that's true, line 9 should print out 3. So let's see what happens. It does. So it got rid of all that extra space. All right, these 2 extra spaces here, trim, just got rid of them. And it doesn't have to be before or after, right? I could put spaces before or spaces after, it will get rid of them. Okay, it still says 3. There are still 3 characters, so we got rid of it. Now, this is a little bit of a long way of writing it. I kind of don't want to write everything on multiple lines. I'm a lazy programmer. So I'm going to chain my methods. So over here, I'm going to do name.trim with the parentheses and then do .length. So now I could do all of that on one line. First, it will take the name, it will trim off the white space, and then tell me how many characters are in it. All right, so there we go. I'm going to go like this. There we go. All right, nice and neat. So trim and length are great ways to work with strings. All right, and there's some other really cool ones. So we'll learn them later when we start doing if statements and comparing things. But for right now, these are really cool methods that you can use. So to review, you got to uppercase, okay, which you can use to make the string all uppercase. You have to lowercase to do the opposite to make it lowercase. You can remove all the white space before and after with trim. And then you can also tell how many characters does the string have with length. These are all methods at your disposal. Sometimes when we're programming, we want to write notes or things for other programmers or stuff to remind us of what we did. These are called comments. Basically text we don't want the Java to think like it's actual code. There's 2 ways to do comments. So you can do a single line comment with 2 forward slashes and then write what you want afterwards. The computer will not think this is code. Okay, normally when you start writing in this area, you would be like string name equals Jonathan hop semicolon. This is code. So the IntelliJ is going to look at this and try to make certain that it is syntactically correct Java. If you write 2 forward slashes and something else after it, that is a comment. That is just for you or other programmers. It will not actually be read by the program. It's just notes you can make for yourself. If you'd like to comment more than one line, so for example, int age equals 100, like if I have multiple lines I'd like to comment out, /* and then on the end of your comment you can do star and then slash like this, and then that will comment multiple lines out. All right, it is useful to use comments to write notes for yourself or notes for other programmers, or to kind of basically take code you've written and comment it out so that the compiler will not see it. Again, as far as Java is concerned, 8 and 9 don't exist. They are not actual code that it will read or do anything with. They're basically just comments. This is something nice to be able to do. All right, let's do basic mathematical operations. So the symbols for those, and I'll put them in a comment, is going to be plus for addition, minus for subtraction, star for multiplication, and slash for division. So after that, it's fairly simple. So for example, we could do int addition is equal to 5 plus 2, right? So you can do plus like this. Int subtraction equals 5 minus 2. And then we'll do int multiplication equals 5 times 2. And then int division is equal to 10 divided by 5, let's say. All right, then I'm going to spell multiplication correctly first. And then I'm going to print out each of these. So addition, subtraction, multiplication, and division. Now that you're saying, my God, Jonathan, you type so fast, I am not typing. Remember, IntelliJ has the IntelliSense. You can hit tab to finish the rest of the line. Practice that. It saves your fingers a lot of headache. All right, there we go. So we got 7, 3, 10, and 2. Now, sometimes you may need to do arithmetic a little bit differently. I'm going to go ahead and let's say we're going to add on to some of these numbers. All right, so let's say we have addition. So let's say, for example, I wanted to take a number. So I have addition, which is now 7s, right? So actually, let me go ahead and start from the beginning. So let's say I have a number, some number, is equal to 10. Now I could take that number and add 2 to it. So I could do some number equals some number plus 2. And I'll print it out. Right? If you want to take the same number and then add 2 to it, you could do it this way as well. I'll go ahead and print it, and then you get 12. There is a shorter way to do this. You don't have to type all this out. I could actually get rid of this extra sum number and then do some number plus equals 2. So what this does is says, okay, cool, take this number and add 2 to it. You can do this with all the other ones. So we could do plus equals, so you'll get 12 in this case. You can do minus equals, times equals, and divide equals. Okay, it's a much shorter way of doing things. All right, so remember, these are the 4 arithmetic operations you can do in Java, and then you can use them as like you would normally in math. And if you'd like to use a shortcut, this plus equals is the same thing as some number equals some number plus 2. It's just a shorter way of writing it. Okay, so this and this are equivalent. Okay, these two lines are equivalent to each other. It's just that one is less typing. Sometimes when we're programming, we end up telling the computer to do something that's impossible. Basically, we have something unplanned for, and the computer cannot actually do the thing what we're asking it to do. So here you have a little program here, which is like kind of a calculator, but it's not the world's greatest calculator because it can only do division. So first we're going to ask the user what number do they want to pick. We'll take that number and save it in this numerator variable. Then we're going to ask them, hey, what do you want to divide that by? We're going to ask them and say, okay, cool, the denominator. And then we're going to print out the numerator divided by the denominator. All right, so let's go ahead and run our program and just try it out. Okay, we're going to do 10 for the first number and 2 for the second. 10 divided by 2 is 5. So everything works great so far. I don't see any problems. But what happens if our user does something wacky? Right? Remember, the user can do whatever they want. So say that we have 10 as the numerator and 0 as the denominator. Well, nothing's stopping me from typing in 0 and hitting enter here. Let's see what happens when I do. I get what's called an exception. Okay? An exception is basically our program has stopped because we've asked the computer to do something it can't do. The computer cannot divide by 0. That is meaningless in mathematics. It is not something we can do. We do not want to cause a black hole in the universe. So what Java will do is say, listen, the user put in 0, then you ask it to take 10 divided by 0. I can't do that. I'm going to throw, the verb is throw, an exception. So it'll say exception in thread main java.lang. It'll have some weird text in the beginning, but you will see the word exception at the beginning of the red error message, and then it will tell you what kind of exception it was. There's different varieties of exceptions because there's different ways that the computer could crash while the program is running. So this is not a very good user experience because basically the program has essentially crashed. What does that mean, you say? So let's try it again. Let's say I put something after line 16. Let's see if this prints if an exception is thrown. All right, so I'm going to run the program again. And then I'm going to put 10 as the top number and 2 as the bottom number. And this is legal. We can do this. So we'll do 5, and it will print out line 18 as you see here. Now let's see what happens if I run my program, but this time cause an exception by dividing by 0. We'll do 10 and divide by 2. Let's do divide by 0 actually. And then it has the exception, and it never got to line 18. As you can see in the terminal, it never printed out. Why? Because line 16 is where the exception was thrown. Once the exception is thrown, the program stops. So it never reaches line 18. So this is not the world's greatest user experience. We have to try to find some way to get the program to keep running even though it hit a roadblock that it can't divide by 0. So this is where try catch comes into play. What we're going to do is we're going to type the word try, okay, with brackets, and then inside the try block we're going to put the code that could possibly throw an exception. Okay, it is possible for this line 17, okay, to cause the program to crash. Why? Because the denominator could be 0. After this left-facing curly brace, we're going to write the word catch, parentheses, and then we're going to write the type of exception. As you can see in this message, it's an arithmetic exception. So we're going to type arithmetic exception, and then we're going to give a variable. This is a type. And the next thing is a variable. This could be potato for all we care, right? It could be whatever you want it to be. We're just going to call it EX. So I don't want to write a lot of stuff. Then curly brackets, and here you have a try catch. So now here's what's going to happen. The computer is going to attempt to do line 17. It's going to try line 17. But if everything goes well, the computer will just keep going on and like normal. If there's an exception thrown, like we tell the computer to do something it cannot do, it will go into the catch block and do whatever is inside of here. So let's put in here, it's like, sorry, the computer cannot do that. Okay, so we'll give them a nice error message basically saying like, hey, you can't do that, but the computer will still go. The program will still run. So with this setup, we're going to try it again where I'm going to put 0 for the denominator, and let's see if line 23 actually prints out. Remember, before it did not. Okay, and before, once the exception was thrown, the program just stopped at that line. All right, we're going to do 10 divided by 0. And then we got this nice little message here. So you see how we did divided by 0. It went into the catch and then ran the code that was inside the catch block. When I say the word block, I mean what's inside these squiggly braces. See how this is catch and then they're highlighted? So it ran this, and as you can see, we actually did reach line 23 because the try catch said, cool, if it fails, do what's inside the catch block and then keep running. So our program did not crash. Try catch takes a lot of practice. So as long as you understand the concept of an exception, telling the computer to do something it cannot do, then you would understand that try catch can allow us to make sure that the program keeps running. Now you may think to yourself, how do I know what kind of exception, what type of exception I should put in my catch block? That is a much bigger issue for right now. Just know that when you have try catch, you can put the type of exception here. For right now, what you can do is if the exception comes up, you can just take a look at the message and see what kind of exception it gives you. That way you know what to put in here. All right, try not to just put exception all by itself, try to be specific. Okay, let's move on. Let's do a little mini project because we've learned quite a bit of Java so far, but we need to learn a couple more things in order to really make an exciting program. So here, I have the start of a guessing game. I'm going to ask the user to please pick a number between 1 and 10, and then we'll let them know they got it correct. We know how to get the user's input with the scanner. So we use a scanner on line 6, and then on line 7, we are able to get the number that they picked by using NextInt. So far so good, but there's a number of things we need to do from here. We need to account for the fact that they could guess the correct number, but they could also get it wrong. So we need to have the program do different things under different circumstances. Another thing is we need to actually generate a random number between 1 and 10 so that the computer can make the game different every time. So these sorts of things allow a program to be more dynamic. So let's first learn how to make a random number, and then we can tell the computer what to do under different circumstances. So in case they get the number correct or in case they get the number incorrect. Java is kind of like an old Victorian mansion, like the kind you read about in novels or see in old movies with like 20 bedrooms and a strange bookcase that spins and weird rooms. I mean, it's a fully functioning language, but sometimes it's got a lot of built-in things that you might not expect. One of which is a random number generator. There is a class called random, which we're going to use to right now to just generate some random numbers. So first off, the class is random, right? And literally it's random. And then we are going to call it a variable. So we'll say random equals new random. Now you're going to have to do an import, all right? So to do an import in IntelliJ, notice how it's red, basically meaning that it doesn't know what this is. So you can hover over it with your mouse, it'll say import class, or you can hit Alt-Enter. So we're going to import class, and notice at the top on line 3, it says import java.util.random. That means that someone else wrote this random class that we get to use to generate random numbers. Without this import, the compiler is not going to know what random on line 7 means. Okay, line 3 is what brings the code in so that on line 7 we can use it. Alright, remember the type is random, and again I named this random because I felt like it. It could just as well be aardvark, alright, and it would be perfectly fine. Okay, but we call it random. Right? Now random can generate a random number. So let's have it create a random integer. So I'm going to do int random number equals random dot, and this is the method NextInt. Then do a semicolon. NextInt gives us a random number, and what you can do is you can basically say what the upper bound of the random number you want is. So let's say I want a number between 1 through 10. So normally NextInt would be able to give you 0. So here's a little trick. I'm going to put 10 in here, meaning that the highest number I can get is 9. Then I'm going to add 1 after it. So if the next integer, so basically this will run, and if it gives me 0, it'll give me 0 and then add 1 to it. That way the lowest number is 1. And then if the highest number it could possibly spit out is 9, and so if it gives me 9, it'll add 1 and give me 10. So I'll be able to get a number, a random number, between 1 and 10. And then I'm going to go ahead and print out that number. So remember the random number is the variable that's going to hold the random number that comes out of this method. So one of the things that's hard for beginners to understand is that these methods, so you know it's a method by it having this parentheses, and maybe something in it or maybe not, that this method will give us back a value. Whatever value that comes out of this method is going to be saved on the left side. So it's going to do something on the right side and then save it on the left side. Okay, so let's take a look and let's run it a couple times. So let's see what our first random number is. Roll the dice. Okay, so we got 8. I'm going to run it again. 7, 10. So as you can see, we can get a random number each time, and that is because of this random class. We're going to use this in conjunction with what we learned so far to make a little bit of a guessing game. Alright, let's work on our game. So we learned about how to create a random number, which is good because our game needs that. I don't want the number to be the same every time the person plays the game. It'd be extremely boring for a random guessing game. Alright, so above here what I'm going to do is I'm going to make an instance of that random class that we did in the last section. So random equals new random. Alright, now this may be weird to you. You may not completely understand what line 6 is doing, but that's perfectly fine. Basically, you could just think of random has this functionality of creating a random number that we need. Alright, so we're going to do int random number is equal to random dot next int, and inside the parentheses we'll do 10 plus 1. This will give us a random number from 1 to 10, and they'll be different every time the program runs, which is fantastic. So then we'll ask the user, hey, please pick a number between 1 and 10. We'll input the number, and now we need logic to handle the different possibilities. So first off, we don't even know if they picked the correct number. Maybe they did, maybe they didn't. So the computer program has to have instructions, okay, for different possibilities. There's two possibilities that we are dealing with. The first one is that they guessed the number correctly. If they did, we would like to let them know that they won. If they did not guess the number correctly, then we need to give them a different message. So a lot of times when you're talking out these scenarios, you notice how I'm using the word if a lot. That is your verbal cue that you're going to use an if statement. An if statement allows the computer to do different things under different circumstances or conditions. So you type if and then parentheses. Inside the parentheses is the condition, like basically under what circumstances do you want to run certain code. So we have this integer, random number on line 7, and another integer, guessed number on line 11. If they're the same, then the person has won the game, right? They guessed the correct number. So if random number, 2 equals, so 2 equal signs, guessed number, and then we're going to do curly braces. Let's break down this syntax. Random number is the random number that is generated. If it is equal, notice I have 2 equal sign, not 1. If you try to just do 1, Java will yell at you, so we need 2. Is equal to guessed number. That means if random number is 5 and guessed number is 5, then this is true. Alright, so this checks to see if this condition is true. If they're the same, then it will do what's inside these curly braces. So if you put your mouse to the right of here, notice how that it lights up yellow and it lets you know like, hey, like these curly braces go together. So whatever happens inside of them, these curly braces will happen if random number equals guessed number. So let's go ahead and do print out winner, winner, chicken dinner. All right. Now, earlier when we discussed this, I said there were two possibilities. Either they guess the number correctly or they do not. Right now, we've handled the first option. They guess the number correctly. But we haven't told the computer what to do if they don't guess the number correctly. That's the other possibility here. If there's another possibility, what we will say is else, and then curly braces. Notice how else does not have parentheses next to it. Why? Because it's for everything else. If it's not covered by the first condition, then it will come to else. So you can think of the program either runs this block of code from 13 to 15, or it runs this block of code from 16 to 18, depending on what the person guessed. So else, we're going to print out, so sorry, better luck next time. Okay, that means that they did not get it. All right, let's run our program and see if it works. We are going to create a random number from 1 to 10. We're going to ask the user, hey, like pick a number. We're going to grab it and save it in this variable guessed number. Then we're going to compare. Is the number that they guessed the same as the random number that was generated? Or if it's not, we're going to give them a message saying sorry. So let's go ahead and run our program. I'm going to compile and let it build, all that good stuff. All right, let's pick a number between 1 and 10. I'll pick 6. So sorry, better luck next time. All right, I'm going to cheat a little bit, and I'm going to print out what the random number was, because otherwise we'll be playing this game quite a bit. I just want to do this just simply for the fact of showing you that it works. All right, so I'm rerunning the program. Okay, the secret number is 3. I am cheating, but I'm going to put 3 and show you that it does something different now. So before I lost, now if I were to actually win, winner, winner, chicken dinner. See how it did completely different things depending on what I typed in? So now with this if-else statement, we are prepared to do whatever, okay, we're prepared for any scenario should the game do something different than what we expect. So the user can expect that the program will adapt to what they do. Alright, our game is pretty fun so far, but I think we can kick it up a notch. So far we have two conditions. Either the person wins or the person loses. Let's add some more conditions. What if we let them know whether or not they were close? So for example, we'll still let them know if they won, but then we'll let them know, hey, your number was bigger or smaller than the random number. So we could say, hey, if the random number was 5 and they guessed 8, we'll say, hey, you guessed your number was too high. And then if they get a lower number, we'll tell them it is too low. That way they get to know, like, which direction they were incorrect. So let's institute that, all right? Now we have 3 possibilities. So if we have more than just 2, we can use this thing called else if. Okay, so it's else if with parentheses, and we'll put a condition here in a second, and curly brackets. So now the computer will either run this block of code, this block of code, or this block of code, depending on what happens with the user. So let's do our condition. So obviously we'll leave lines 14 through 16 the same. If they got the number, then they win. And then here we'll do if the guessed number is greater than random number. So this is the way we can compare numbers. And if they got it bigger, we'll say the number you guessed was too high. All right, let's break this condition down. Remember, the part here inside the parentheses is the condition. So we have this greater than sign, and remember, if you remember from math, this is how you compare numbers. If you don't remember, as a kid, I was taught that the alligator eats the bigger number. So guessed number is bigger than random number. And there's other symbols. There's greater than, less than, greater than or equal to, or less than or equal to. So you have those at your disposal, okay, inside this condition where you're comparing numbers, which is really great. So we have 3 options. The first option is that they guessed it correctly. The second option is they went over. So let's change this else statement, because remember, there's only 3, so we don't have to do else if guessed number is less than random number, because there's only 3 options. So we're going to change this message and say the number you guessed, past tense, the number you guessed was too low. All right, so now they'll know in which way they were wrong, which I'm sure is very fun for the player. Let's start it up. I'm going to hit this green run button. All right, now I'm cheating. I know what the random number is. Obviously, in our real game, we wouldn't have this, but let's say I do 6, right? 6 is greater than 5. The number you guessed was too high. Let's play it again. All right, let's do 3. The number you guessed was too low. All right. All right, and then if I pick lucky number 7, winner, winner, chicken dinner. All right, so that's pretty cool. So now we can do different conditions. So if you have more than just like 2 possibilities, you can use else if. The cool thing with else if is you can have as many as you want. Like, let's, for example, like, you have like, well, there's only 3 here, but you can use as many else's as you feel like. So you can have if, else if, else if, else if, else if, and then else, okay? At the end, you're going to put else for everything else, basically. All right, so before you program, you're going to have to think to yourself of what all of the possibilities that there are. This is especially difficult for beginners because you're not used to thinking in that way. Human beings don't think in like these trees where they just go down all the possibilities and have them all in their head. That's probably new thinking for you. All right, but this if, else is the technique that we can use to represent all the possibilities of our program beforehand. That way the computer can react, okay, based on what the user does. All right, let's continue working on our guessing game. So far we've been using if, else in order to account for whether or not the number is correct, too high, or too low. Let's add another requirement. Let's say that we want to give them a really special message if the number was 7. So let's say that the random generator spits out 7 and then they guess it, and we'll say like lucky number 7. All right, so there's a couple ways we can do this, but what I wanted to show you was that you can have multiple conditions, okay, inside your if statement. So for example, let's say that they say, okay, cool, the random number is equal to the guessed number. After this, you can add a symbol, okay, called ampersand, so put 2 ampersands, and let's say the random number equals 7. Now, what does this mean? What this means is that the random number and the guessed number have to be the same, and the random number has to be 7. So this condition on the left and this condition on the right of the ampersands has to be both, they have to both be correct in order for line 23 to actually print out. Okay, and so now we're going to have a special thing that says jackpot lucky number 7 with multiple exclamation points. All right, and then what we'll do is else if, and then we'll just say, hey, they just guessed the number, but it wasn't lucky number 7. That's fine. We'll just go back to winner, winner, chicken dinner. So notice how I have multiple else ifs now. So now we have another thing. If the number they guessed is correct and the number that they guessed was 7, then we'll give them this special message. Otherwise, we'll continue on with the else ifs and the else. So now you can see that you can put multiple conditions inside your if statement in case that applies to your situation. All right, let's run the program. Let's see what happens. All right, it's 8. So if I get it correct, it will just say winner, winner, chicken dinner because yes, it's correct. So you see here it says that random number equals guess number. So they're both true in this case, but random number was not equal to 7, so therefore it went down to line 25. Let's do it a couple more times. Let's see if we can get 7 so we can see. Okay, there we go. So now you can see the random number 7. I'm going to put 7 in here. Jackpot, lucky number 7. There we go. All right, so now we can use multiple conditions. And is the first one. You also can use or. Okay, so you can do this where it's either one is true. So either the number that they guess is correct or the number is 7. So let's say that the rule is now if they roll a 7, then if the random number was 7, the person automatically wins. All right, so now if they guess the number correct or if the number that is randomly generated is 7, they will do line 23. So let's give it a try. All right, so it's 5, so I'm going to go ahead and guess it correctly, and notice that it will say jackpot lucky number 7. Why? Well, it went to line 22 and looked at this condition. This is true. So if one of these two things is true, then it will go to line 23. They don't have to both be true, all right? If either one of them is true, it will do line 23. So that's where the or comes in. So this is when you have either which one could work. Otherwise, you use and when you need both of them to be true. All right. So now you know how to do multiple conditions, and you can do as many as you want in here. Okay. You have and then or. Okay. You have multiple conditions inside an if statement. My personal recommendation is just try to keep it to like 1 or like 2 or 3 at most, because if you try to like make it too complicated, it will make your brain hurt. But now you can use and or inside your if statements to really do some excellent and very complicated branching off. So now you can handle a lot of different scenarios in your program and handle the user input in a very skillful way. All right, now that we know more about if statements, let's work with strings. All right, in the guessing game, we just have to work with numbers, but now let's use if statements and compare strings together. So I've got a couple variables, first, second, and third example, and first and second are basically the same thing. They're both x, y, z. Third example is a little bit different in that it is x plus y plus z. I'm taking these 3 strings and sticking them together. Now I'm going to print them all out just so we can see how they look like. There we go. See, if we can see they all look the same. So now we have to figure out whether or not they equal each other. So the first two should probably equal each other because they're the same thing, right? So let's do if first example equals second example. S out, hit. All right, just something simple. I want to just basically see if this condition turns out to be true. Does first example equal second example? Well, let's run. And if we see it print out to the screen, we'll know that, hey, it hit. Awesome. All right, so now what about first example and third example, right? This will print out x, y, z, but in as in code, we haven't actually made x, y, z. We've just added these things together. So try to think about it. What do you think? Will first example be equal to third example? So if they are equal, we will see line 15. So let's run it. Correct? They are still equal to one another. All right. So even though they're broken up, it's a little bit of a quirk of Java, but you will notice that it still will say they're equal to one another. Okay, typically for strings, what you should do is use equals. So there is an equals method. So after the dot, we can do equals, and so you check to see if the first thing equals the second thing. The thing you're comparing it to goes inside the parentheses. So we could, for example, do third example. So if first example dot equals third example, then we'll see if it hits this time. Okay, still a hit. All right, with strings, equal is pretty much preferred. There's another way to make strings. Let's make another string. I'll make a fourth example. So I'm going to do string, fourth example, equals new string, and then I'm going to put a string inside here and put XYZ. All right, so this is using that new keyword. We saw this before with the scanner. Okay, we're going to learn more about it when we do objects coming up. But string, I'm going to make input XYZ, and then I'm going to also print it out. So fourth example. All right, I'm going to get rid of this if statement for the moment. I'm just going to put some comments here. Okay, I use Control / to comment multiple lines in IntelliJ. You highlight them and just do Control / Okay, I'm going to print everything out just to show you what it looks like. Okay, they all look the same. So now let's figure out if these are equal. So let's go ahead and see if first example equals fourth example. They should, right? Because it says XYZ, that says XYZ, they all said the same thing. Let's see if there's a hit. No, there is not. Okay, that's interesting. Well, that's weird. They both say XYZ, right? This is why you should use equals. So let's use .equals and then put fourth example in here, and now let's see what happens. It says hit. That's weird, isn't it? Right? So not to get too far into it, but essentially when you do .equals, it will look at the content of the string and compare them as opposed to looking at what's called their reference. You don't have to understand what that is right now. What you should remember is when comparing strings, you should try to use .equals. So you take the first string that you are comparing, .equals, and then inside the parentheses, the other string you are comparing. Let's continue our exploration of comparing strings now that we are handy with if statements. I've got two strings here, a variable called first example, which holds the value of Avengers, and a second variable called second example, which holds the value of Avengers, but lowercase. Now, sometimes you want to compare strings, but you really don't care if one is uppercase or lowercase. So let's go ahead and see and compare these just as they are. So I'm going to do an if statement and do if first example dot equals second example, then S out, the two are equal. Right, let's run our program and see what happens. Doesn't print anything out. Why? Because the first example is all caps and second example is lowercase. Even if I were to change one of the letters to uppercase, it still would not register as equal. Right? Because when Java looks at the two strings, it's trying to make certain that every single character is exactly the same. Now, sometimes we don't really care if both of the strings are exactly the same in terms of uppercase and lowercase. We just care that these, the letters themselves are equal. So we have another method that accounts for this. We're going to do .EqualsIgnoreCase. Okay, so now we're going to do first example .EqualsIgnoreCase, second example. Now we're going to run and see what happens. Okay, the two are equal, right? So in the case that you don't really care what the case of your letters is, then you can use EqualsIgnoreCase. If they have to exactly match, then you need to use equals. It's up to you which one you want to do, all right? But these methods are both available to you when working with strings. So now you can make your if statements really do some work. This EqualsIgnoreCase is very useful with user input. So for example, I'm going to get rid of lines 8 through 10. And we're going to do a scanner equals new scanner system.in. All right, and then we're going to do S out, and then we're going to basically ask the user, please give us your name. And we're just going to have a really silly rule that basically says if they put the name in Jonathan, we will put a special message in. So we'll do string current name is equal to scanner dot next line. Alrighty, so we're going to have them put in their name, and then if current name dot equals, okay, we're going to put Jonathan, S out, welcome back Jonathan. It's our special message, right? It's a silly program, but you'll get the idea. Now, let's run it and see what happens. All right, please give us your name, and then if I type in Jonathan just like this, it'll give me back this. But the user does not have to do what we expect them to do. What happens if they do like this? then nothing happens, right? Even though the name Jonathan was put in there, because current name dot equals Jonathan, that didn't work. Okay, so since that's not the case, then nothing happened. Now you could say, well, Jonathan, what if we just did this? Well, what's to stop the user from putting something bizarre in? Like, for example, okay, like multiple different capital letters and lowercase letters. Okay, so in that case, equals ignore case is great, all right, because that way we don't really care what the user, like whatever silly thing the user put in. Okay, as long as the values are the same, the letters are the same, then we'll be fine. So that way, if I run my program again, except this time with equals ignore case, I could put like this, and then bam, this is welcome back Jonathan, right? This accounts for the user's possibly weird input. Remember, the user does not have to give us input or data in the way that we expect. They are free to do what they want, and as programmers we have to be able to accommodate for them. And so now equals ignore case is in your toolkit of what to do with strings when you're comparing them. What if we wanted the computer to do something a certain number of times? Like, let's say I wanted the computer to print out something 10 times or 20 times. I guess I could write out, system.println1, systemout.println 2, but this would be really boring. All right, like if I wanted to do numbers 1 through 10, I could do this 10 times, but that would be tedious and boring. I think there's a much better way to do something a certain number of times using Java. So we're going to learn a for loop. All right, so the for loop is used when you want to do something a certain number of times. All right, so we're going to do for. Okay, you'll notice it's a keyword because it's labeled in orange, and then you'll have parentheses, and afterwards you're going to have curly braces. Now, let's go see what happens inside the parentheses. First off, we need a variable that's going to hold our for loop. So basically, it's going to tell us at what point in the loop are we. It could be aardvark potato. Typically, people use I, and it's an integer, so we're going to do int I equals 0. This first part basically says, I like to start the loop off at 0. You can have this start off at whatever you feel like, but let's go ahead and let's do it at 1. The next part is, hey, how do I know to keep going? Okay, like how do I know that I should continue the for loop? Because remember, the computer is going to do this over and over and over again until we give it a condition to stop. So we want to basically say, okay, cool, I want you to do this loop so long as I is less than 11. Okay, so long as I is less than 11, continue the loop. What do I do at the end of the loop? At the end of the loop, we're going to do I plus plus, which basically means add 1 to I. So this is a lot that's going on inside this for loop. There's 3 basic things. The first part is what number do we start off at? The second part is how do I know to keep continuing? And the last part is, once the inside of the for loop runs, what do you want me to do with the variable? So we start off at 1. I would like the loop to continue so long as I is less than 11, and then we're going to do I plus plus at the end of the loop. Now you're thinking to yourself, okay, cool, we did all this. Now what do we put in line 9? That's up to you. So what we're going to do is we're going to print out the variable I is, and then we're going to do plus I. Because I want you to understand what I actually is. Okay, so that this loop is actually going to increment I throughout it. So now what we're going to do is we're going to run our program, and we will see what happens. Okay, I'm going to make this a little bit bigger. So the variable I is 1. The variable I is 2. Notice how the first thing it prints out, I is 1, is the same thing as here. That means that this part is where the loop starts off at. Okay, so once it's 1, okay, cool. Is 1 less than 11? Yes. Then continue the loop. So therefore, it printed out line 9. It finished line 9. We're at the end of the loop. And then what do we do at the end of the loop? We add 1 to I. Then do it again. Then I equals 2. Is 2 less than 11? Yes. Print out line 9. The variable I is 2. And then once that's finished, I plus plus, add 1 to I, making it 3. So it will continue doing this over and over and over again, as you can see, 4, 5, 6, 7, 8, 9. Now we get to 10, and this is the interesting part. So now here I is 10, right? So we printed out I is 10, we got to line 10. We add 1 to 10, it's 11. Then we get to this part. 11 is not less than 11. Okay, so if we were to replace this I with 11 so you could see it, 11 is not less than 11. That does not make sense. That is not true. Since that is not true, the loop stops. Okay, notice how there is nothing printed here saying the variable I is 11, right? That's because the loop stopped, because this was no longer true. The tricky part about for loops for beginners is this I. You don't really know what this is doing. You have to understand that this variable is constantly changing throughout the loop. I did this example to show you what I is at each part of the loop. This is great for if you would like to do something a certain number of times. So for example, you want to print out all the numbers between 1 through 10. You want to loop through a list of students and print out their student IDs. A lot of times in programming, we want to do something multiple times, all right? And for loops are a great way of doing that. You can set up a for loop like this to do it a certain number of times. Remember, there are 3 parts. What number do you want to start off at? Okay, and again, you can make this 0, you can make this 1,000, you can do whatever you want to do there. How do I know to continue the loop? Okay, as long as this is true, we will continue the loop. And then at the end of the loop, what do you want me to do with I? You could do I++, have it go up. You could even do I minus for have it go down. All right, so let's actually try this one out. So let's start with 11, and let's change the condition to I is greater than 0. I minus. So now we're going in the opposite direction. I'm going to run my program. Let's just see what happens. So it starts off at 11, and as you can see, it goes down by 1 for each time. So remember, this code is generating all this. We did not have to write out S out 11, S out 10, S out 9. That would be tedious and boring and awful. Okay, I don't want to do all that. Instead, I could write this right here between 8 through 10, and then I could produce this output with just that much code. That's why for loops are useful. They can help us do something multiple times and have to write out a bunch of code. Here, we have the number we're starting off with. How do we know to continue the loop? And then which direction? Do we want to add something to I? Do we want to subtract from I? Okay, you can do what you want here, how you want to do things. And then you can do a for loop and do something multiple times. Sometimes you want the computer to do something until you tell it to stop. While loops are great for that. So let's learn how they work. All right, so I am going to make an integer. I'm going to call it I and make it equal to 1. Great, and you could just as well call it a potato or anything else you want. Okay, we're going to use while, so it's going to be while, and then inside we're going to have a condition. So basically the inside of this parentheses says, okay, cool, like check this to see if we continue the while loop. So I'm going to do while I is less than 10. Right? So while I is less than 10, I want to do everything inside these curly braces, inside the while block. So we're going to just do a simple S out and hit tab to do system out.println. And I'm going to say I is currently, and then do plus I, and there we go. And then we're going to do I plus plus at the end. All right, let's print this out and let's see what happens. So I will start off at 1, and the while loop will do everything in here over and over and over again so long as this is true. So technically it should print this out and then increment I, and then let's see what it actually does. All right, so I is currently 1, 2, 3, all the way up till 9. Now here is the interesting part. So I gets up to 9, right? 9 is less than 10. System.println I is currently 9. Okay, I plus plus. That means 9 goes to 10, all right? Then we go back up to line 7. 10 is not less than 10, right? So I is 10, so we can replace the I with 10 in our head, and this is not a true statement. 10 is not less than 10. So therefore the while loop stops. So you might be thinking to yourself, well, like, how is this really different from a for loop, right? Like a for loop, we do something a certain number of times. A while loop, it looks like very similar. Do something so long as this condition holds true. Well, while loops are great for instances where we really don't know when we want to stop, but we essentially want to keep doing something until you tell it to stop, essentially. So let's do a little of scanner magic. I'm going to make a Boolean saying, for example, is running game equals true. All right, so that's my Boolean. Is running game equals true. All right, so I'm going to do while is running game equals true. Then we're going to basically say, okay, cool. So long as this Boolean is true, I want to do what's inside my while loop. So let's go ahead and ask the user a question. So I'm going to use a scanner we used before, equals new scanner, system.in. All right, we're going to ask the person, like, hey, do you want to stop? Okay, we're asking, like, do you want to get off the ride, basically. And so we're going to then say string response. Well, let's make this a little bit easier. 1 for yes, 2 for no. All right, so 1 for yes, 2 for no. Okay, if they type in 1, then we say, okay, cool, we will stop the ride. 2 for they want to continue. All right, so we'll do int response is equal to scanner.nextInt, which will grab what they type in as an integer. And then if, now we use our if statement that we used before. So now we have two branches. If response is equal to 1, then I'm going to set this Boolean is running game to false. Let's see what happens, right? Let's review our code first before we run it. While is running game equals true. So I have a Boolean up here that's set to true. So it will start off because on line 7 I set the value to true. So clearly this line 11 is true for the moment. It will print out, hey, do you want to stop? 1 for yes, 2 for no. Then we'll actually get what the person typed in after they hit enter. If they typed in 1, I'm going to flip is running game from true to false. Let's see what happens. Hey, do you want to stop? 1 for yes, 2 for no. If I hit 1 for yes, it exited. Process finished with exit code 0. It looks like it broke out of the loop. What happens if I do 2? It asked me again. So the while loop started here. I gave it a 2. Okay, the if statement didn't do anything, right? If response equals 1, well, response was 2. So therefore, it goes all the way back up to line 11. And then we'll do it again. So now we're back up on line 11. I'm going to go, it has asked me, do you want to stop 1 or 2? It's now on line 13. I'm going to go hit 2. Okay, it went here. The response is equal to 2, so it goes back up to line 11. So we'll go from line 11 all the way down to line 17 and back up. And over and over and over again in a cycle until this is no longer true, right? So I'm at line 11, it did line 12, we're currently at line 13, I'll hit 2. It will go all the way down here and then start right back up here. Okay, it's a loop. It goes through all these lines over and over and over until you tell it to stop. Now when I hit 1, because now we're here, when I hit 1, then we're going to check to see the response will be 1 and is running game will be false, and I'll be able to break out the loop. Okay, so the loop has finished. So this while loop is great because a for loop will be kind of awkward here. We don't know how many times the user is going to press 2 to continue the loop. We have no idea. We just really care if the user wants to stop the loop by pressing 1. So this while loop is great that I don't need to know how many times I need to loop through something. I'm just basically saying, hey, loop through this code over and over and over again until I tell you to stop. That is a great use for a while loop and what separates while loops from for loops. To review, a while loop begins on line 11, it has while with parentheses, and then inside you put a condition. In this case, it's a Boolean whether or not we're running the game. Is running game equals true. Inside the while block, you can put code just like you normally would. I print out, do you want to stop? 1 for yes, 2 for no. We decided to collect the user's information, and then if the response is 1, then we set is running game to false. Then when the while loop gets to line 18, it will come back up to line 11, but running game is false. So if running game is false, this is no longer a correct statement, so therefore the while loop will end, and we will break out of it. Java is an object-oriented programming language. You're going to call that OOP. A lot of people will say OOP, object-oriented programming. And it's a style of programming, right? It's one of different kinds of styles. There's also like functional programming, for example. But an object-oriented, the way we organize our software is in different classes. These classes represent different things. They could represent real world things like employees and customers and games and electronics. They could represent actions like things like whether or not you can fly or not. Object-oriented programming has been the main programming paradigm for decades, honestly speaking. And so learning it, and Java really kind of leans heavily into it, right? So Java is very, very into the object-oriented programming paradigm. So that means then that our software is going to be subdivided into classes. Now we already have a main class here, which we've already created, and I just called it main because I wanted to call it main because this is going to contain our public static void main string r's, which is the entryway into our program. But we're going to need more than one class. Like most real-world programs have tons of different classes with tons of different things in them. So let's get started with the basics. Now I'm going to go over to my package that I created when I first made them. I made a project called class example. Then I created a package in my Java folder called com.classexample. I know it's a package because the icon shows this little dot inside of a folder, and so that's how I can differentiate this between this package and just like a folder like main. Alright, cool. Right click on the package and do new and Java class. And you notice that you have other options here, but we're going to just leave class highlighted, and then I'm going to call it customer. Alright, couple things about naming classes. Okay, first off, you can name your class with a lowercase letter. So if I want, you will not be stopped. So if I did like, for example, I'll just call it example, this has a lowercase e, then it would be fine. You could do it. People tend not to do that. People tend to write their classes with a capital letter as the first letter. And I'm going to do that as well. And that is a convention that you should follow. Okay. Another convention is that the names of classes should be nouns. Okay, because it's a thing, right? So it's a customer, it's an employee, it's an animal. Okay, it is a thing. It is something. All right. Now we have this public class customer, but what can we do with it? All right. So the customer class is going to contain information that pertains to a customer. It allows us to take a more complex idea like customer, all right, and then be able to bundle data all in one package. So all the stuff inside the squiggly braces is going to be pertaining to our customer, right? So our customer in the real world will have a number of different pieces of data or information we may need to keep track of. And the customer may do certain things, which we can use methods. So classes are going to be able to bundle information, and they're going to be able to bundle functionality all together. So let's think about a customer in our program. So the customer probably has a first name and a last name and maybe an address, okay, maybe an age. These are different pieces of data about a customer. We can write fields inside the class to represent those pieces of data. So the first thing we're going to do is we're going to have to figure out whether or not we're going to allow things outside of the customer class to be able to access these fields. So typically with the field, you're going to make it private. Okay, so you have two options here. You can make it private or public. All right, let's start with private first, and I will show you the difference between the two of them. So first we start with private or public. Then the next thing we do is the type. Is it a string? Is it a Boolean? Is it an integer? Like, what is it? Okay, so let's think about their first name. Their first name is probably going to be a string. That makes the most sense. And then we'll give it a name. Let's go call it first name. All right, that's our first field. A customer is a thing that has a first name, and the first name is a string. We can do the same thing with the last name. So I'll do private string last name. Then let's do age. Private int age. And then I think we are good. Let's add one. Let's make a Boolean. Let's do private Boolean is premium member. Okay, whether or not they have premium membership. Like, let's say that this is some sort of like subscription model where they are a premium member and they get special stuff for doing that. Okay, cool. So now, so far, we've got a customer that has a first name, a last name, an age, and whether or not they are a premium member. We had a breakdown of these different fields. We had the access, the type of variable, and then the name. And again, these names, the common beginner mistake is to think that the computer actually knows that this is the first name. We just declare this first name. We could just as well have said aardvark here, okay? And everything will work just the same. All right, let's talk about this public versus private part because that is the thing that actually confuses people the most. Let's go ahead and create a new customer. This is where objects and classes come in to shine. Let's head back to main.java and get rid of this comment. And I'm going to do customer, let's call a new customer, equals new customer. Now there's a lot going on line 5. First off, we're using this like a type. Like previously, in other recent videos, we're doing string, new string equals some string, right? This is the type of thing it is, and this is the name of the variable. Well, line 6 is doing the same thing. What type of thing is this new customer variable? It's a customer. So that means that classes basically allow us to make our own custom types. We don't have to do Boolean, string, and int, and float, and double. We can do our own custom ones as well. So now we have customer, new customer equals this new keyword, customer. Okay, so now what I'm basically saying is, hey Java, I've got a blueprint for a customer. Could you take the blueprint and then instantiate, okay, a customer for me? So now I have a customer I can work with. All right, let's explore this variable here, new customer. If I do new customer and do dot, notice that I have a bunch of methods that come with objects, but nothing of what I saw or what I wrote in the customer.java. All right, let's leave this here for a second. Let's come back to customer.java. Let's change this private string first name to public string first name. Now let's come back here to main.java. I'm going to do dot again, and look, first name pops up. So maybe thinking, what on earth is going on? How did that like show up all of a sudden? So for example, I could do maybe new customer.first name is equal to Jonathan. Okay, it popped up all of a sudden. Why? Public means allow other classes or things outside of this class to be able to access first name. Okay, so if it's public, that means that other places, like in main.java, anything outside of these squiggly braces can access it. So I can do new customer dot first name equals Jonathan. Okay, because we're in the main class, we're not in the customer class. If I switch it back to private, then notice that IntelliJ starts yelling at me because it's like, hey, this is not available anymore. You can't do line 8. It will not compile. I've got red all on the side and everything. All right, so that is the difference between public and private. We've got some fields. All right, and so if we made them all public, let's go ahead and do that. Okay, one at a time. Oops. And then one last one. So if I make them all public, then they're all available. So I can take this customer, say his first name is Jonathan, new customer dot last name is equal to Hop, and then new customer dot age is equal to 1,000. That's how I feel today. And then new customer dot is premium member equals true. So now we've got a customer and we're able to fill out information about the customer. Here's the cool thing about object-oriented programming. In our software, in the real world, obviously we're going to have more than one customer, and all our customers are going to have different ages and different names, and some will be premium members and some will not be premium members. Let's make another customer. Customer, second customer equals new customer. And this second customer can have a completely different name. So second customer dot first name is equal to Bob. His last name is equal to Bob. His age is equal to, let's say, I don't know, he's 35. And then second customer dot is, and he's not a premium member. So now I've got new customer, which has this information, and a second customer, which has completely different information, but it follows the same pattern. All customers have a first name, a last name, an age, and are they a premium member or not? All right, so all customers share the same basic template, okay, for how the data, like what data exists and what type of data is. So I can have a customer, create a new customer, and fill in all this data. And in the real world, I can account for the fact that I'm going to have different customers with different first names and different ages, okay, which is quite realistic. All right, so now we're able to create a class and then make some fields and decide whether or not they're going to be public or private. There's still a lot more to classes to go, but at least you get the basic idea of this is how the core of object-oriented programming. I get to have classes and objects that mimic or model real-world things, and I can basically have one object have certain values, have another object have utterly different values, and that reflects what goes on in the real world. All right, so now we know about public and private. We know about instantiating our classes. We know how to create a class, right? There's a lot more to go. Let's talk about the constructor next. All right, let's take a look at our customer class again. Now, I've set all the fields to private, and so you may be thinking to yourself, well, Jonathan, if all these fields are private, then how are they ever going to be set to anything? Because if I try to create a customer, so do customer, new customer equals new customer, like this, then I can't actually set the customer's first name or anything like that because they're all private. I don't have access to them, right? That seems kind of counterproductive. Well, what I'd like to do is sort of create a blueprint for how to create a new customer. Right now, when we do new customer, we don't provide any information as to the customer's name or their age or any of the other things about the customer that we may need to know in order for our program to function. So really what I would like to do is when someone creates a new customer, I would like for them to give me the information I need in order for the customer to do its work, for it to have all the information in the right place. That's where a constructor comes in. So I've got my first name, last name, age, and its premium member. All that's good to go. After this, I'm going to write a special method. So constructors are methods. They're special methods. They have the same name as the class. So it's going to be written like this: public customer. And you're going to be like, well, this was like a method. We've been using methods on strings that end with this parentheses, and I would say yes. Notice how this is exactly the same name as the class. I did public customer, and then I put parentheses and then squiggly braces. All right, now inside here is going to be a list of variables, information that I want to have when you do new customer. All right, so when you do new customer, there's some information I want to have. The first thing I want to get is the first name of the customer. Then I would like the last name, then the age, and whether or not they are a premium member. Okay, notice that this and this are the same, right? That they have the same name in terms of being a variable. However, they're not exactly the same thing. We're going to see that in a second. This is what is being passed into the customer. So you're saying, well, Jonathan, what does that mean? Well, if we go back to main, notice how IntelliJ is all angry at me now because it has like these red squiggly lines. It's basically going to tell me that, hey, you're missing information. Expected 4 arguments but found 0. So it's expecting 4 pieces of information, and then also IntelliJ tells you the order in which it's expecting them. So it's expecting a string, which will be the first name, another string, an int, and then a boolean. So we need to give this information here. So let's say I did it here. So we'll do a string first. We'll do Jonathan. Then we'll do another string, hop, and notice how it actually even says the variable name and then a colon and then the value. And then we'll do age, 100, and then I am a premium member. And now IntelliJ has been satisfied. So now when you do a new customer, you are providing these values. You are saying that this is the information that I need in order for a customer, to exist. Let's go back to our constructor. We get these from the person who does new customer, but what do we actually do with these variables, this information? We need to set our fields to whatever value is coming in. So if the first name is equal to Jonathan, then this first name is equal to Jonathan. Common beginner mistake is because they think that, actually there's 2 common beginner mistakes here. First off, just because these variables have the same name does not mean they are the same. All right, they actually hold different values. The second thing is people seem to think that the computer knows that this is first name and that they should be matched up. They think that these variable names have some magic powers. I just call this first name because that whatever value gets put here is going to be put in the first name. I could just as well have called this aardvark. Okay, and that would have been perfectly fine. People aren't going to do that because that's confusing, but you could. All right, let's set our fields. We're going to do this dot first name equals first name. Now you're probably extremely confused, and the this keyword has confused developers for decades upon decades. All right, you're not the first person to not understand this. This basically means this customer, this instance of a customer. Okay, it's referring to the customer itself. So this in this specific situation refers to this customer. So it's going to take Jonathan, the string, put it into the first name variable that you see here on line 9. Okay, and then it says, okay, cool, this object, it has a field called first name. Set that field's value to what is coming in. We're going to do the same pattern with last name, age, and is premium member. Okay, so now we will be able to set all these things from the constructor. And again, the naming is just for not being confused. I could just as well have called this aardvark. Okay, and this will work just the same. Okay, now it will look weird, and other developers might, give me the side eye, but it will work perfectly fine. The computer is not making decisions. It is not looking at the name of the variable or knows which one is which or by the order or whatever. It does not do that. The other common beginner mistake is, so I'll undo this, is typically we do things in order. So for example, notice how the first field here was first name. So the first thing I put inside the constructor was first name. It doesn't have to be in this order. All right, you can do whatever order you want. I just tend to follow the same order so that everything is kind of like follows the same order, because that makes it a lot easier to read and a lot faster. Okay, it's less confusing if everything kind of stays within the same pattern. Right, these patterns don't have special meaning. I'm just doing it because I've been doing this for a while, and sticking to the same pattern makes these classes a lot easier to read. You'll notice that as you get more used to them. All right, so this constructor is pretty much a go. So now when we create a new customer, we can set what the first name, the last name, the age, and whether or not they're a premium member right when we create the customer. And just like object-oriented programming, we can make a variety of different customers. All right, so we can have Natasha Romanov, who is 32 and of course is a premium member. Okay, and then we can have another customer. Third customer equals new customer. And we'll do, I don't know, Steve Rogers, whose age is 120. Okay, he didn't spring for premium membership. So now we can have different customers with different pieces of information, right? And we put them into the constructor. That way I know that those pieces of information come in. Remember, if you have a constructor set up, and I try to do, let's say, fourth customer equals new customer, but I don't put anything inside of these parentheses, then IntelliJ will complain at me, and I will not be able to build or run my program, because the constructor is perfunctory. You must, if you have a constructor in your class, you must, provide these values. They must be of the correct type. So, for example, I couldn't put like a number here. Okay, so notice how that this is, I put 10, and it's expecting a string. So you notice that IntelliJ is complaining, saying required type string provided int. So this is very strict. The first argument has to be a string. The second argument has to be a string. The third one an integer. The fourth one a boolean. All right, and that is because we set it up this way. If I switch this around, right, that's fine. Java would run, and then it would just be switched around. Okay, so you have a number of rules when you have the constructor, which is nice, because now when I create a new customer, I know that these pieces of data are being set. It's not going to be like left empty when I'm not expecting it. All right, now the next question you may be thinking to yourself is, well, that's cool, Jonathan, but still, like, I have a new customer and I can't actually figure out any information about the customer, right? I know what it is from the constructor, but with variables change over time. Like maybe the person buys premium membership and it goes from false to true. How am I going to like check to see if that's changed, or how do I change it myself? Well, the next thing we're going to learn is getters and setters. All right, here we are back in the customer class, and we would like to start making some getters and setters. Okay, these are functions or methods that allow us to give access to these properties. Now, we prefer this method. You could make all of these public. You could go public first name, public last name, but what we like to do is have methods that are responsible for getting and setting these values, right? To keep these fields private, and then to allow other people, like people outside of this class, to only have to be able to use those getter and setter methods in order to deal with the customer class. All right, that means that the internal state of the customer, meaning the values of these variables, is only changeable, right, through our getter and setter methods. And this is the typical pattern that you will find with classes. All right, so we can do this by hand first, and then I'll show you in IntelliJ how you can just basically generate them, just as they follow the same pattern over and over again. All right, so again, this is a private string first name. We're going to do first name first. We're going to do public string, okay, get first name, right, and then some squiggly brackets. Now notice I began it with the word get and then first name. So this is camel case. And getters, as you can guess, begin with get and then the name of the field that they are getting. So all I'm going to do is return this dot first name. Okay, this keyword can be very difficult for beginners. Basically, you can think of this as this customer. All right, so back in our main.java, we had multiple customers, right? So new customer, this refers to this customer, right? So if we did this dot first name, you get Jonathan. But for this customer, this dot first name would give you Natasha. So, right, so always it's like self-referencing is the way I usually think about it, right? Okay, this object's first name. That's it for the getter. It's really simple. So if you want to do some other getters, we can do public string get last name, and then just return this dot last name. So now that we have this getter function back in main.java, if I would like to get the value of just the first name, I've already created new customer, I've got the constructor, but now I want to get new customer dot get. See, now the getter is here, it's public, so therefore I can grab that value. All right, so there's kind of like, you can think of it like one way in and one way out with classes. Okay, so first name, this is how we get it, and then we can do the getters for age. So public int get age, return this dot age, and you can see the pattern is pretty repetitive. Public boolean is premium member. Okay, return this dot is premium member. All right, nice. All right, so we made some getters. All right, now what if I want to change these values? Like, let's say, for example, that Jonathan grows 1 year older, and his age goes from 100 to 101, right? Ripe old age of 101. All right, so then we're going to have setters. And it's going to be very similar, all right? So we're going to do public void set, let's do first name, set first name. Now, since first name is a string, right, we need to have a parameter into this method that allows us to change the name. So it's string name. What this is what name do you want to change it to? That's coming into the method, all right? What name do you want to change it to? Then all we have to do is this dot first name is equal to name. Bam, that's it. So now we are able to set the first name. So let's see this kind of in action. All right, I'm going to s out, so system.out.println line, let's do first name before change, plus new customer dot get first name. Then we'll do system out after change plus new customer dot get first name. So we're going to do kind of a before and after photo. Sandwich in between, I'm going to do new customer dot set first name Murgatroyd, right? Because that's a weird name and I enjoy that. All right, so we're going to run our program. So it's going to show us what the name is first. Then we're going to use a setter, and then we are going to print out what the name is now. You'll see the difference. So let's run our program. Okay, first name before change, Jonathan. After change, Murgatroyd. All right, so there you go. So now you understand what setters do, right? So this Murgatroyd, this string, okay, that we put into this method, is going to be, that value, Murgatroyd, is going to be saved in this variable name. Okay, that's the big thing for beginners to kind of like, because it's in two different screens, it's very confusing. But this Murgatroyd comes over here, and then we say, okay, cool, this dot first name equals, in this case, Murgatroyd, or whatever it is that happens to be. All right, and then the setters are going to pretty much follow the same pattern. So if you're doing like int for age, public void, set age, int age, this dot age equals age. Now, if you're thinking this is kind of repetitive, you are correct. This is very, very repetitive. So some very, very smart programmer or someone who worked for IntelliJ, or I'm not sure who this person was, but they should have a statue in their honor. They made it so that we don't have to actually like write all these out by hand. So what I'm going to do is I'm going to hold down Alt, the Alt button on the keyboard, and hit Insert. And that will bring up this little menu, and it says Generate. So we're able to generate these getters and setters. And what that means is we're allowed to let the IntelliJ just create them for us. So here I clicked on getters and setters. I'm going to highlight everything. I'm going to hold down the shift key, and then click at the bottom so everything is highlighted. I'm going to hit OK. Okay, and there it is. We do not have to do that all by hand. All right, all the getters and setters are generated for us. And yes, you can generate a constructor as well, so that way we don't have to do all this stuff. Now this is very typical way for a class to get set up. You've got your fields, okay, like what makes up a customer, what information do we need for a customer. We've got a constructor, all right, so when we create a new customer, what information do we care about, what information do we need? And then we have getters and setters. That way people are not directly dealing with these fields. They do not directly change them or manipulate them. We basically say, hey, if you want the value, you got to use one of the getters. If you want to change the value, you got to use one of the setters. All right, this is a very common pattern of working with classes, so practice it for a little while, and you should feel really good with Java classes because you're going to be working with a lot of them. Before we discuss getters and setters, let's talk about methods in your class. So I know we talked about methods related to strings, like to uppercase, to lowercase, things like that. But you can make your own methods in your own class, right? So your class is kind of like a blank canvas, and you can sort of paint on it how you wish with the tools that we have. All right, so let's make our first method in our class. This is our own custom method. It's not a pre-built Java method. It's going to be a method that we make that does something that we want. All right, let's have a method that prints out the name of the customer. All right, the first part of a method in a class, so when I say it's in a class, notice that the squiggly braces here, the curly braces, this marks the beginning of the class, and this marks the end of the class. All right, so it's kind of like the zone in which the class is in. You can think of it that way. All right, so the first part of the method is going to be the access. Is it public, private, other? So usually you make it public. Okay, for right now we can make things public. Public basically means that, hey, it's available outside the class. It can be used in other places. You also have private, which basically means, hey, this method can only be used inside the customer class, meaning it can only be used inside these two squiggly braces, right, inside the scope of the customer class. Let's make ours public to begin with. All right, so we have public. Now we need to know, what does our function return? You can think of a function like a little machine. You put something in, you get something out, right? You put something in, it does some work, it spits something out. I think of it like a toaster. You put bread in, you hit the button to get started toasting, it does, the electricity turns on and other things happen, and then out comes toast. All right, so the part that comes out, right, is what is returned. So if we're going to say hi, I don't necessarily want to return anything. So I'm going to do void. Okay, if you don't want to return anything, you do void. All right, so we're going to do public void, and then we're going to give a name for our function. Again, this is just like when we name variables. It's whatever we want to name it. All right, we tend to use camel case, so lowercase letter for the first word and uppercase letters for any other word, and we try to make it all kind of run together. So for example, we're going to call this method say hello. Then we're going to put parentheses and then squiggly brackets. All right, so public void say hello parentheses squiggly braces. Right, so this method doesn't return anything. Okay, it just runs and doesn't return any value. No toast pops up. Okay, and nothing comes in it. Right, I'll show you what to do with these parentheses in case you want to work with them, but let's just do it the simplest way. So public void say hello, and what we're going to do is just do s out, so system.out.println hello, my name is, and then we'll just have them introduce themselves, this dot first name. So hello, my name is, and then plus this dot first name. All right, well, we made our first method in a class. It's a custom method. It does exactly what we want it to do. It's not pre-built. All right, now how do we use this? Well, it's public, so that means in main.java it's available. So I'm going to get this stuff out the way. And I'm going to do new customer dot say hello. So say hello is a method relayed to the customer class. So as you can see, I can do new customer and then dot. And then when I did the dot, IntelliJ brought up some possibilities, one of which is my custom method, say hello. All right, and now we're going to run the program and see what happens. Java compiles. Hello, my name is Jonathan. See, there we go. All right, so our method did exactly what we wanted to do. Cool, right? So now you can make your own methods, which is what you're going to be doing a lot when you're programming, just in general. Now, back to this public-private stuff. So if I made this a private method, then what would happen is that I would have a compilation error. And I'd hover over this red squigglies and say, hey, hello has private access. So it has private access, meaning I cannot use it elsewhere. I am not currently inside the customer class, so therefore say hello. It's not possible for me to call this method. So therefore, that is what private does. So sometimes you want methods public, sometimes you want them private in different circumstances, but as Java gives us kind of this ability to pick and choose what we think is best. All right, now, what we can do is we can spice this up a little bit. All right, so what we can say is maybe we want to have them, I don't know, say their name a certain number of times. Okay, so we don't know how many times, so we want to give the person using this method the option of picking how many times the person says hello. So we're going to do int, we'll call it count. Now you're wondering, what the heck is this? This is a parameter. So what we can say is that when you use this method, when you call this method, you can give us a number, and we'll use that number inside of our method. IntelliJ is telling me, hey, there's a problem. I'm going to click on this one related problem. It's saying, hey, like you said that I'm supposed to get a number here, but there's no number, so I need you to fix that. I'm going to put 2 here. And you can put really any number you want. I don't really care, but you'll notice this is count 2. Notice how that the variable here is called count, and IntelliJ says it matches it up. So count, the variable here on line 16, the value will be 2 when I run this. All right, and then let's do it like a for loop. So we'll do for int I equals 0, I is less than count, I plus plus, right? And this is just for fun, right? And we'll have it say, and we'll do the system out that print line inside of our for loop. So take a second, and remember it's important to type. So type this out, okay? And we're gonna have it basically loop through as many times as the function tells us to. So let's do something a little more than 2. Let's do 3. All right, then I'm gonna run my program. Okay, hello, my name is Jonathan. It's printed 3 times. Okay, so this 3 was passed in as an argument to the say hello method. Okay, that 3 became this variable in count, and then inside the method we can go ahead and use count. Now remember, this method, this variable here, count, is only exists inside the method. So if you ever have if you're ever wondering like the scope of a method, you can click to the side of a squiggly brace, and it will highlight its matching squiggly brace. So the variable count only exists in here. So for example, I can't put count here because it's not inside the method where I declared the variable. All right, so count doesn't make any sense inside the constructor or elsewhere. It just makes sense inside this method. Okay, and it's all right to make a mistake because IntelliJ in the compiler will let you know, and you will not be able to run your program, okay, if a variable is out of scope. So don't worry too much about that. It will basically put you back on the correct path. Well, all right, we've made a method. All right, so what happens if we want to return a value though? Like right now we have void. Okay, so void just means we don't return anything. All right, let's change this up a bit. Right now we're printing something to the screen. Let's make another method. Let's call it public. And what we'll do is I like to combine the first and last name. I like a method to take the person's first name and last name and combine them together. I don't want to have to like separate the two. So that way I have their full name. So we'll do public string get full name. All right. Now you may be wondering, what is this string doing here? Well, this function is going to return something, just like the toaster. I put the toast in, I hit the button, it pops out. The stuff that pops out is the return. So what I want is to return this dot first name plus a space plus this dot last name. All right, now this return keyword is very important. Couple small details. If you put something here like string, int, boolean, there's a bunch of other things you can return. Okay, you can return pretty much what you want, almost. All right, any sort of type, any of the stuff we've been learning, string, int, boolean. Okay, later on you'll be able to get more fancy with this, but right now you can return a type. Okay, and then if you say that you're returning a type, you must return it. So right now, my code will not compile. You'll see this red squiggly brace here because it's missing a return statement. Okay, so missing return statement. All right, so that means I need a return statement. I can't like run my program. All right, secondly, because I said string here, I'm going to comment this out one more time. I can't like return whatever I want, right? I can't return 0. 0 is not a string. And because it's not a string, I can't return 0. I told it it's returning a string, so it has to match. All right, so in this case, I'm returning this dot first name and this dot last name. Okay, one of the big misconceptions with return for beginners is they think that return prints something to the screen automatically. All right, I'm going to get rid of this say hello. I'm just going to do get full name. Okay, I'm going to run my program. Okay, you notice that nothing came to the terminal. That's because this does not give you back. It doesn't print anything to the screen. So you're wondering, well, what's the point of this? It doesn't seem to do anything. Well, we can hold its value in a variable, for example, or we can just use the method. So let's go ahead and print out the first name. So I'm going to do system.out.println. I'm going to put this, okay, as a variable. So I'm going to do string full name equals new customer.getFullName. So now what will happen is this. New customer has a method called getFullName. The computer will run this method, okay? It will come to the customer class and say, okay, cool, this is their first name plus a space plus their last name. It will take that string and return it and save it in this full name variable. Then I'm going to print it out, full name, like this. For you fancy folks, you could do this on one line, all right, but I want to do it in multiple steps so people can see what's happening. All right, so I'm calling the get full name function or method. It returns a string, which I am saving in this variable, and then I'm going to print it out. All right, let's run our program, and there we go. There's the full name. So this way we can use the return from a method to do some work, all right? So if you do not want to return anything, you choose void. If you want to return something, after the word public or private, you need to pick a type, okay, of what you want to return, be it int, double, long, whatever you feel like, and then the name of the method, okay? First letter is lowercase, then if there's other words in this little sandwich, you need to make them uppercase. And then any variables from the outside world you need in order to do your job should go inside the parentheses. You'll put the type first and then the variable name, just like it's no different than the pattern you see up here, except without the privates, okay? So you're going to put any variables here. If you have more than one, you can separate them with a comma. And you can have as many in here as you'd like. So int count, double another variable, string something. Okay, one after the other after the other. You get to have as many in here as you'd like. Okay, if you say that the method returns something, you must have the return keyword, and it must return the same type. So this is a string, so this is a string, they both match, therefore it's fine. You can't just do whatever you want. Thank you for watching part 1. If you enjoyed this video, please like the video and subscribe to this channel. And if you really liked it, then please consider joining us on Patreon to ensure that there is more beginner-friendly code content on YouTube.